Hey guys, welcome. Yeah, so I have a really fun video for you here. The talk show host Conan O'Brien would always say at the start of every show, I have the best show for you here. And he says that every show. I do have a really awesome video for you here. And it's on complex numbers, additional practice. Yeah? Okay, now I already have a very well crafted playlist on complex numbers in polar form. So watch those videos, complex numbers in polar form, in order for you to fully understand this video. That is, if you don't have the necessary background to understand this video. Okay, cool. But otherwise, here's our delicious question. So z1 and z2 are complex numbers. And we know that the product z1 times z2 is this. So when we multiply z1 and z2, we get this. And when we divide them, z1 over z2 specifically, we get this, right? The order matters, right? So z1 over z2 as opposed to z2 over z1. So z1 over z2 is this. Yeah? Okay, cool. Now, the question, as you can imagine, is what are z1 and z2? All right. Now, why we love complex numbers in polar form, my form, right, is because, well, polar form of a complex number makes it very easy to multiply complex numbers, and it makes it very easy to raise them to large powers subsequently, and it also makes it very easy to divide them. So what we're going to do is, since our task is to figure out what z1 and z2 are, we're going to say that z1 and z2 assume polar form. That is, we're going to say that z1 is equal to r1 cis theta 1, and we're going to say that z2 is then naturally r2 cis theta 2. Now, again, watch those earlier videos on the polar form of complex numbers so you can get the necessary background, as I said. But really quickly, any complex number in polar form can be written as r cis theta, and what that means is r cosine theta plus I times r sine theta. So this here is saying r1 cosine theta 1 plus I r1 sine theta 1. That's what this means in full interpretation. And so this then naturally has a very similar interpretation. Now that we know that z1 and z2 look like this in polar form, from those videos on multiplying complex numbers in polar form, we know that z1 times z2 is going to be r1 times r2 cis theta 1 plus theta 2, right? And also, we know that z1 divided by z2 is going to be r1 divided by r2 cis theta 1 minus theta 2. And this we know because, well, from those videos where we derived multiplying two complex numbers and dividing them, we know that this is the result in polar form if z1 and z2 look like this, right? Why do we want this? Because we have information about z1 times z2. It's specifically this complex number. And z1 over z2 is this complex number. So what we could do is we can compare this here in polar form to what we have here. What I'm saying is we're going to change this to polar form and then compare it to this. And we're going to change this to polar form and compare it to this. Yeah? Now, I'm not going to show you the details of how to change this into polar form and this into polar form, because those details are what I discuss at length in those videos, earlier videos that I already mentioned. Perhaps too much mentioning them, that is. Now, from what I just said, we know that z1 times z2 is this. It was given. And so if we convert this to polar form, it's going to turn into 2 cis 240. So z1 times z2, which is this complex number, turns into this in polar form. So this here and this here are identical. It's just that this is the polar form and this is the rectangular or Cartesian form. And z1 over z2 is this, we know, and this 2i in polar form is 2 cis 90. And in fact, if you write out 2 cosine 90 plus I times 2 sine 90, you'll be able to see that this is exactly 2i, right? Okay. So, as I said, comparing this here to this here, which is what z1 times z2 would look generally, comparing these two, we can claim that r1 times r2 is 2, and we can say that theta 1 plus theta 2 is 240. And similarly, we can say r1 divided by r2 is 2, and theta 1 minus theta 2 is 90. So let's write that down. So what I just said is we'd write theta 1 plus theta 2 is 240, and we'd say that theta 1 minus theta 2 is then 90, and the r equations are r1 times r2 is 2, right? And r1 divided by r2 is also 2, and that's this. Okay, cool. So now we have a system of equations in thetas and a system of equations in r's. So we can definitely solve this because we have two unknowns and two equations for the thetas, and again, two unknowns and two equations for the r's. So if we start with the r's, then from this equation, we can see that r1 is equal to 2r2. So starting with this and substituting for r1 with 2r2, we can write this. Again, first, from this equation, we see that r1 is 2r2. And then we see that since we already wrote r1 times r2 is 2, substituting 2r2 for r1, we can write 2r2 times r2 is equal to 2. So this says 2r2 squared is equal to 2. Now, that means that r2 squared is equal to 1, from which we gather that r2 is plus or minus 1, right? Okay, cool. And now what that means is r1 is plus or minus 2 because we said that r1 is 2 times r2, and we just said r2 is plus or minus 1. Okay, very important though, is when r2 is positive 1, r1, which is 2r2, will be positive 2. And when r2 is negative 1, then r1 will be negative 2. So r2 being negative 1 means r1 is negative 2, and r2 being 1 means r1 is positive 2. Yeah, very important to keep that straight. In fact, so important that I'll write it down. So when r2 is positive 1, r1 is positive 2, and when r2 is negative 1, when r2 is negative 1, then r1 is negative 2, as I've already said. Okay, cool. And we can easily solve for theta 1 and theta 2. In fact, what we're going to do is we're going to add these two equations. You should have seen how to solve system of two equations and two unknowns. It's pretty straightforward. So if we add the two equations on theta, what we're going to get is, notice that the theta 2's will drop out. We're going to get 2 theta 1 is equal to 240 plus 90. So I believe that's 330. So 2 theta 1 is 330, meaning that theta 1 is 165. And of course, then we can use either of these two equations to figure out what theta 2 is, and theta 2 is going to be 75. All right, cool. We've got everything we need in order for us to completely determine Z1 and Z2. Specifically, we have R1 values, we have R2 values, we have theta 1 and theta 2. So what that means is we are basically done. So this is what that means. If we make space, we have a pair of solutions. So Z1 and Z2 may be 2 cis 165 and 1 cis 75. Note the R1 value and R2 value that we very specifically pointed out in this part. And then the other pair of solutions are to let Z1 equal negative 2 cis 165, and therefore Z2 will equal negative 1 cis 75. Yeah? All right, cool. I thought that this was really cool. It's not the hardest problem you can do on complex numbers in polar form, but it's a pretty interesting one. And so I hope you thought the same. Keep watching. Take care.